Hey everyone! So I'm taking a look at the warm-up that I provided for you guys in class today. And I know a lot of you guys are probably pretty insecure about the whole Graham's Law thing, so I thought I'd just help you out a little bit. So the traditional Graham's Law formula that you got, say, from like the textbook and from the vodcast that I gave you before, looks something like this. Rate A over rate B is equal to the square root of the molar mass of B over the square root of molar mass A. But I don't know if you knew this, you can actually rearrange this formula to make it look a little prettier. I kind of like to see this formula rewritten as the following, so let me show you. What you can do is you can take the rate A, make sure you square that, multiply that by the molar mass of that first one, A, and then set it equal to rate B, make sure you square that rate, times the molar mass of B. And I think sometimes looking at that formula that way makes a lot more sense. So if you take a look at the first gas, nitrogen, it says that it diffuses 20.8 centimeters in 5 minutes. Now, this rate in the formula can mean a couple different things. This could actually be for us the speed of the movement, which is distance over time. Distance divided by time. But what it could also be, since we're talking about gases, is it could be the amount of the volume. So the actual amount, so like I could say like liters over time. So rate could be represented in speed, or it could be a specific amount over time. So for example, it could be meters per second, it could be centimeters per hour, or it could be the actual amount that it moves. So like, let's say that 5 liters moves over a period of 24 hours. So rate could either be how fast the particles are moving, or the actual specific amount that moves in a specific given amount of time. So for us, A is going to be nitrogen, and B looks like it's going to be krypton. So the first thing you're probably going to want to do is figure out the molar masses of these items. So let's do that. Find the periodic table, and let's look up the molar masses of these two gases. So here's some of the information that we have from the problem. I've got the molar mass of nitrogen and krypton, and I've got the rate of nitrogen. What we don't have is the rate of the krypton. Now, if you read the question carefully, it's not asking for you to solve for the rate of krypton. It wants to know how far it would go in the same amount of time. So we're actually going to have to solve for the rate first. And then if you have rate, think of it as being kind of like speed, how fast it's moving. If we figure out the rate of krypton, all we have to do is, once we solve for speed, multiply it by 5 minutes, because it's asking how far it would go in the same amount of time. Alright, so let's plug it into the formula we've got here. So A is going to be nitrogen. So I know that the rate of nitrogen is 28.0. Oops, that's not it. Sorry. Gotta erase that. Sorry. So we know that the rate of A is 20.8 divided by 5.0, because that's 20.8 centimeters divided by 5.0 minutes. And don't forget to square that value. The molar mass of A is 28.0 grams per mole. Okay. Rate B, we are trying to solve, so I'm going to put R here, and don't forget to square it. And the molar mass of B would be krypton, and this is 83.8 grams per mole. Alright, so let's do a little bit of simplification on your calculator, so make sure you have a calculator out on your desk. What I'm going to do first is I'm going to actually solve for that silly thing in the parentheses that squared the rate of nitrogen. So on your calculator, what I'm doing is I'm going to go 20.8, and I'm dividing by 5. Okay, now I've got an answer on my calculator, but what I want to do is actually square that. So make sure you square. And for this chunk, this piece right here, I got 17.3056. Now look, we probably want to multiply that by this number right here, 28.0. So I'm going to go ahead and multiply by 28.0. And when I do that, I actually got this value. I'm going to have to erase because I'm running out of room. So watch this. I'm going to take this part right here. I just solved for the entire left side. And I got 484.5568. That is equal to r squared times this 83.8. So I want to try to solve for r. I want to get it by itself. And if you've got the 83.8 multiplied by that r, I need to get rid of it. So I'm going to take this value right here, and I'm going to divide by 83.8. And I'll do it over here too, right? Because that's going to cancel it out. All right, so I'm taking my answer that I have on my calculator and I'm dividing by 83.8. Okay, now that will make this fraction. I'm going to simplify that fraction, and now what that is 5.7823, and it keeps going. But basically that is what is equal to, I got rid of this piece over here, that's equal to r squared. So how do I get r by myself, or by itself? That's right, you got to do the square root. So I'm going to do the square root of 5.7823. All right, I got about 2.40 is equal to rate. Now, up here, when we first did rate for nitrogen, it was in centimeters per minute. Whatever unit you used on that first one, that's a unit for this value as well. So this 2.40 is actually how many centimeters per minute the gas will move. Now, if we let it diffuse for the same amount of time in the original problem, which is 5 minutes up here, all I have to do is take my 2.40 and multiply that by 5.0. All right, so 2.40 times 5.0 will give you 12.0 centimeters. And that, ladies and gentlemen, is your final answer. That is how far krypton will travel under the same conditions in the same amount of time as nitrogen. I hope this was helpful. Thanks, guys. I'll see you soon.